All right, part 3. So we're looking at number 28 right now. It says your teacher is giving a test that has 12 more 3-point questions than 5-point questions. So another more 3-point questions. So I'm going to write the equation F equals 12 plus T. So F for 5, T for 3. All right, I'll switch them back to X and Y once I see what's going on here, because these are awful similar, and I want to make sure that I have the right X with the right 3. So in like problem C here, or answer C, it's X minus Y equals 12, and then that means X is the 3-point question, which I don't think is going to be right. And then we're going to have the total test is worth 100 points. So if I went 3T plus 5F equals 100. So if I knew how many test questions there were of each, I'd multiply the 3-point questions by 3, the 5 by 5, for a total of 100. Now all of these equations I see in the answer choices are in standard form. So I'm going to move the T over in this problem. So I'm going to get F minus T equals 12. All right, so it looks like F is going to be my X value, which means the X needs to have a 5 next to it. So it is a minus, so A and B are out. So I'm looking here, and then again I'm seeing that my F, it's F minus T, so 5-point questions minus 3-point questions. And again, this is my X, so it's down to C or D, and then remember my X needs to be the 5-point question, so that gives me D for this one. All right, can be a little tricky, but just work your way through that. All right, now we're into chapter 7 stuff. So power to power, product of powers, all that stuff. So let's get started. We did pretty well on this during the school year, so let's just get into it. So here we have a power to power rule, and that simply says that we multiply these powers. This is m to the 4th times m to the 4th, which is m to the 8th. The fast way to do it is just to multiply 4 and 2. Okay. For 30, we have some power to power, and then we're going to have some like bases, add exponents when we're done. The issue that most students have with problems like this is they forget to raise 2 to the 4th power. Okay, and if a couple of other things to think about. This is negative 2 4 times, so it's positive. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So 2 to the 4th power is positive 16. Then we have x to the 4th, x to the 4th, y to the 8th. Again, I did power to power here. 2 times 4 is 8. X to the 1st to the 4th is x to the 4th. And then I'm going here. 2 to this 2 squared is 4. X to the 6th, y to the 8th. All right. And then we're going to make this multiplication. So I always just take care, now that I don't have any exponents on my coefficients, I'm just going to do 6 times 4, which is 64. X to the 4th times x to the 6th. This is a like base add exponent situation. That's x to the 10th, so I added my exponents. And then y to the 8th times y to the 8th is y to the 16th. All right, I think I'm going to switch markers here, so I'm going to pause it real quick. I got a pencil. We'll see how that shows up. The next problem, y to the 5th times y to the 3rd, is just a like base. They have the same base. We add the exponents, so y to the 8th. How does that look? Yeah, we can see that. All right. And then this is a straight, when we're dividing like bases, we subtract the exponents. The answer always starts in the numerator. If it's negative, we can move it afterwards. If you're really good, you can do it all in one step, but my suggestion is just to do the 7 minus 4 is 8 to the 3rd. It's positive, so I don't have to do anything else to it. All right, let's see what happens in number 33, though. I can divide 6 and 2, and 6 divided by 2 is 3. And actually, my tip during the school year is to start with a fraction bar and then just put things where they need to go. So 6 divided by 2 is 3. 3 is the numerator. And then this is a like base subtract exponent. So negative 3 minus negative 1 is negative 3 plus 1, which is n to the negative 2nd. And then y, this is one where we struggled with on the quiz. Y to the 1st minus negative I'm sorry, 1 minus negative 3 is actually 1 plus 3, which is y to the 4th. All right, and now I'm going to move anything with a negative exponent. The 3, there's no special connection with this n and this 3. They just happen to be next to each other. I could switch the y and the n, and it wouldn't affect the 3 at all. So the 3 is not moving. The n is, and when I move the power here, I change the sign of the exponent, and then that leaves me with y to the 4th. So that's our answer for number 3. Okay. 34 is going to be similar. So what I like to do is, let's see, how am I going to handle this one? Part of me wants to move this down to the bottom right away, but then I got a pretty big, messy bottom. I might just actually go power to power first, which is not usually what I do, but I feel like that's going to help us out here, because we're going to have one positive, a negative, and a positive, so we're going to be flipping 2 anyway, so we should be okay. So let's power to power this. So that's going to be a to the 12th b to the negative 24 over a to the 12th and b to the negative 24. Okay, so glad I did it that way. A to the 12th divided by a to the 12th. If you don't see that's 1, we can do a like base, subtract exponents. 12 minus 12 is 0. Anything to the 0 power is 1. So that cancels out. And negative 24 minus negative 24 is negative 24 plus 24, which is also b to the 0 power, which is also 1. So the answer to that is 1. Then it says we have this one to do, so let's try it. 4m, I'm going to write them vertically because I think that helps everybody out. Okay, so there's that. And what I am going to do now is I'm going to get rid of this negative by flipping that fraction. Okay, I think I'm going to simplify right now as well. M squared divided by m is just m. So m squared divided by m to the first, 2 minus 1 is 1. So that's m over 4 to the 3rd power. And then I just hit this with m to the 3rd is m to the 3rd. And 4 times 4 is 16. 16 times 4 is 64. So there's our answer for that one. All right, express this scientific number in standard notation. So we did well on this on the test, but just to be clear, when you raise something to this 10 to the 7th power, it gets really big. So this is going to be a large number, and we're moving it 2 spaces past the 45. That leaves us with 5 more zeros. 1, 2, 3, 4, 5. I'm going to check it just to make sure. So we're here. 1, 2, 3, 4, 5, 6, 7, and that is our answer. Throw in some commas to help me out, and we got what, 84,500,000. All right. Now the exact opposite happens here. We have 214. The decimal is there, and we're going to move it back 7 because this is a really small number. We're actually dividing by 10 to the 7th if you think about it, moving negative exponents. So we're actually going to move this back, move it back 3, and that leaves us 4 more zeros. And again, I always like to check it. 1, 2, 3, 4, 5, 6, 7. So we are good. That is the answer to 36. All right. Could you guys see that? Actually, I don't know if you could. Let me show you what I did there. All right, again, I just moved it. It was here, and I moved it back 7. Okay. All right. 37. That last one was 36. Yep, 37. So looks like we have an exponential here. Which equation corresponds to the graph shown below? All right. So we want to look at a few examples here. So I see it's crossing at 2. And if I put 0 in for x here, I really don't like how it's written, but if I put 0 in for x here, that makes it 3 to the 0, which is 1, and 2 times 1 is 2. So I kind of like this one. I don't like this one. This one, if I plugged in 0, right, I'm thinking y-axis here, okay, and that means the x value is 0. So if I plug in 0 here, that becomes 1 plus 1, which is 2, so I guess this could be the answer. And then, yeah, I don't like that. If I plug in 0 there, I also get 2. So we're going to have to, oh, and we're up, right? So we're not getting close to 1, which means I'm down to F or J because this moves up our graph 1. All right. So let's see if we can find another solid point. This looks like a solid point right here. So 1, 1, 2, 3, 4. So I'm really just kind of thinking of it like this. Okay. Oh, that's a Y. So if I plug in 1 for X, okay, I'm hoping to get 4 out of one of these two here. Okay. So when I plug in 1, 3 to the first power is 1, and 1 plus 1 is 4. So we are at F there. Okay. So a couple of things I was looking at, where, and I checked 0 as well. All right, where it crosses the y-axis, and that's putting in 0 for x, just like it is in anything else. Oops, sorry, I don't know if you could see that. And then I noticed that we didn't actually approach 0 like we did in most of our graphs. We're approaching 1. So that means we're a shift up 1. That's going to be outside the exponent. That's why that one doesn't work. Okay, and this essentially is 6x plus 1. So if I were to plug in 1 here, I'd have been at 7 way up here at 1. So that's why I chose F. All right, you'll have graph paper on the exam, so if you really want to graph it out, but I was just trying to show you with what they gave us. Let's take a look at a population growth problem. How much time we got? We should be okay. All right. City's population is about 763,000 and is increasing at an annual rate of 1.5%. Predict the population of the city in 50 years. So this is just an exponential growth. Remember, we have our initial value times, and we're increasing, right? Increasing. So 1 plus this percentage as a decimal, which is, there's 1%. So just have a 5 next to it, and that's 1.5. And we're going to go to the 50th power, and I have to find a calculator. So hold on. All right, the only one I can find at my house is my phone, and you can't see the numbers when I put it under the camera. So I'm just going to talk to you about how I handle this. If you're good, you can put it in as one shot. I know a lot of kids mess that up, so if it were me, I would take care of this parenthesis first, and I'd just type in 1.015 to the 50th. I got to find that on my calculator here. Let's see. There it is. To the 50. And that gives me like 2.10 something. I'm going to leave the whole number in there, and then I'm going to multiply it by our initial. And that gives me a value of, let's see here, 16062. That's bam. Yeah, so our population would go from 763,000 to 1,606,299 in 50 years. Okay, so that number feels right to me. All right, number 39. Printing press is valued at 120,000 and depreciate. So this is almost the same type of problem, but instead of 100% or 1 plus our 1.5 or 0.015, we're going to be subtracting that. Okay, so I still start with my initial value, and 100 minus 12 is 88 or 0.88. All right, and we want to know what it's going to be in 7 years. So again, I'm going to go to my calculator, and I'm going to do, how much time I got? Ooh, I got to do this fast. 0.88 to the 7th power. I'm going to multiply that by 120,000. And that gives me a value of, that can't be right. Did I copy that down wrong? Oh, no, that's right. That's 120 was our starting. Yes. So, $49,041. And if you're really keeping track, 7 cents. So, yeah, we started at 120,000. It's depreciated at quite a fast rate, 12% per year. So, it's worth $49,041. I will complete the rest of this on the next video.